Impressive, right? In this video, I'm gonna show you how a quadcopter can actually perform this type of trajectory. This is long exposure, by the way. If you cannot see my previous videos, I suggest you to watch it because it relates to this one. The first thing that we're gonna need is a flight controller, a flight stack. In this case, we're using a NACE32 and a Raspberry Pi that they are working together and talking together. In this example, I am actually flying the vehicle manually using Wi-Fi. This technique is called RC override. The next step is designing a position controller that will hold the vehicle in a specified position inside the laboratory. In this case, the vehicle is holding 0, 0 and 1.6 meters, regardless the disturbance I make to it. The next step is actually using some math to generate the X and Y trajectory that the vehicle is going to try to follow, is going to try to track. This is done by using sines and cosines and specifying a time in which the circle is going to be complete. Once that we know that the trajectory is working and that the vehicle can actually perform it, we proceed to do it experimentally. In this example, you can see the vehicle starts to move in the laboratory doing the actual circle trajectory. This trajectory, it will take around the vehicle around 10 seconds, no, exactly 10 seconds to complete the circle, as you can see here. But of course, 10 seconds is too slow, right? We need to push the envelope and we need to make it faster. So we're gonna do it at 4 seconds. The vehicle has 4 seconds to complete an entire circle trajectory. This is the fastest that this vehicle inside this laboratory can go. If we make it faster, we risk of losing stability and maybe the vehicle will shake. Okay, but what about if we want to do something more interesting and not just a common circle? So we want to do then a figure of eight trajectory. A figure of eight trajectory is very common when doing this type of position controllers. The first thing we have to do is select which figure of eight or infinity trajectory we want to do. I like the one that is following the red dot because that is the one of the lemniscate of Bernoulli. So I choose that one. I did the math for that one and generated the X and Y trajectory. And then I put that trajectory into the Raspberry Pi, and the Raspberry Pi is going to calculate the necessary roll, pitch, yaw, and throttle movements for the vehicle to follow that trajectory. But of course, let's speed it up. Then again, this is the fastest trajectory that the vehicle can perform inside of this lab and with this vehicle configuration. It's doing the lemniscate of Bernoulli in 6 seconds. So 6 seconds it takes to do the entire figure of eight. Impressive, right? There's no pilot that can actually do that. We have to consider that this is an automatic pilot, this is an automatic trajectory, there is nothing involved here. I just activate the trajectory and the vehicle will perform it by itself. as a bonus, here is my vehicle orbiting around me. Thank you for watching.